Good morning everyone. I am Edeline Tulang and welcome to my channel. Today we are going to discuss about the basic integration. For today's lesson, we are going to discuss about the exponential function, algebraic function, logarithmic function, and trigonometric function. Our objectives today is to learn on how to solve basic integration and have knowledge about its principles and concepts. Let us write the basic integration. Basic integration. First, we have the algebraic function. We have here the algebraic function, and then, we have 5 basic integration formulas for algebraic function. We have formulas. Number 1 is the integral of 0 dx is equals to c. Next is number 2 is the algebraic integral of a dx is equals to a integral dx is equal to ax 1 over 1 plus c. So don't forget to write c in your final answer. Number 3 is the integral of ax dx is equals to a integral of x raised to 1 dx is equals to ax. So you will add here plus 1. So you have 2 over 2 plus c. So number 4 is integral of ax squared dx equals a integral of x squared dx. So we'll add here again plus 1, so you have x cubed over 3 plus c. And then the last is the integral of ax raised to n plus 1 raised to n dx is equals to a integral of x raised to n plus 1 dx over n plus 1 plus c. So this is our power formula. This is the power formula. So let's erase this and have an example for algebraic function. So let's have an example for our algebraic function. Example 1 is the integral of 4x squared dx. So first thing we do is to take out the constant number. That is the 4, then copy the integral x squared dx. And then next is to integrate. So you will add here plus 1. So you have 4x 3 over 3 plus c. Or we can write it as 4/3 x raised to 3 plus c. So this is the answer. So to check if our final answer is correct, so this is check. So derivative of 4 over 3 x cubed plus c is equals to 4/3 multiplied by 3x squared equals to, let's cross out the 3, and the remaining is 4x squared. So that is 4x squared, and this is 4x squared. So that's it. So let's erase this and have an example for exponential function. So next is the exponential function. We write exponential function. So let's recall in the differential calculus, the formula of exponential function is d over dx e raised to bx is equals to e raised to bx multiplied by b. So in integral calculus, the formula of exponential function is integral of e raised to bx dx is equals to e raised to bx over b plus c. So this is the formula for exponential function in integrals. So we have here the example. We have example. Number 1 is the integral of 1 over e raised to 2x dx is equals to integral of e raised to negative 2x. That would be negative because e raised to 2x, we transpose it as our denominator, as our numerator. And then copy dx is equal to, so e, let's copy e, and then raised to bx or raised to negative 2x over negative 2, plus c. This is the final answer. So number 2 is integral of e raised to 3x dx. So we have e raised to 3x over 3 plus c. So that simple as that. So let's go to the logarithmic function. So now we are going to have an example for logarithmic function. So let's recall the formula on our differential calculus. The formula of logarithmic function is d over dx. Ln x is equals to 1 over x. So in integral calculus, we have the formula for logarithmic function, which is integral of a over x dx is equals to a ln of x plus c. So we have that formula. So for example, number 1 is the integral of 3x raised to 3 plus x squared minus 5 over x dx. So we have to integrate this into 3. Let's copy 3 and then x, and then 3 plus 1 is 4 over 4 plus x, 2 plus 1 is 3 over 3 minus, let's take out the constant number which is 5 and then apply this formula ln of x plus c. Or we can write it as 3/4 x raised to 4 plus 1/3 x raised to 3 minus 5 ln of x plus c. So this is the final answer. So let's go to the trigonometric function. So this time we are going to discuss about the trigonometric function. So as we recall the formula for the differential calculus in trigonometric function is this. D over dx sine dx is equals to the derivative of sine dx is cosine bx multiplied by b, and then the derivative of cosine dx is negative sine bx multiplied by b, and then the derivative of tangent bx is secant squared bx multiplied by b, and then the derivative of cotangent bx is equals to cosecant bx, cosecant squared bx multiplied by negative cosecant bx multiplied by b. And then the derivative of secant bx is secant bx tangent bx multiplied by b. And then the last is the derivative of cosecant bx is equals to negative cosecant bx cotangent bx multiplied by b. So, in integral calculus, the trigonometric function formulas is the integral of sine bx dx is equal to negative cosine bx over b plus c. The integral of cosine bx dx is equals to sine bx over b plus c. So the integral of secant squared bx dx is tangent bx over b plus c. So the integral of cosecant squared bx dx is equals to negative cotangent bx over b plus c. So the next is the integral of secant bx tangent dx is secant bx over b plus c. And then the integral of cosecant bx cotangent bx dx is equals to negative cosecant bx over b plus c. So as you can see, their signs are not the same, or let us say they are reversed. So let's have an example. So example for trigonometric function is integral of cosine 2x minus sine 3x plus secant squared x over 3 dx. So we have the integral of cosine, which is the sine 2x over 2 minus the integral of sine is cosine 3x over 3. Oops, sorry. The integral of sine is negative cosine. So we have two parentheses here plus the integral of secant squared is tangent x over 3 over 1/3 plus c. So we can write it as 1/2 sine 2x minus, or it can be negative times negative, that is positive cosine 1/3 cosine 3x plus the 3 tangent x over 3 plus c. And this is the final answer. So let's move on to our next lesson, the u substitution. So first we will erase this. So next is our u substitution. So we have first is our objectives is to learn how to solve the u substitution. So we have here the formulas for u substitution. So first is integral of u raised to n du is equal to u raised to n plus 1 over n plus 1 plus c. Next, that is the integral of du over u is equal to ln of u plus c. And then next is number 3 is the integral of e raised to u du is equal to e raised to u plus c. And then the last is the integral of a raised to u du is equal to a raised to u over ln a plus c. So that's the formula for u substitution. So next we are going to have an example. So we have example number 1. Number 1 is the integral of x dx over x plus 3 squared dx. So let u is equals to x plus 3. So our u can be found inside the parentheses, or sometimes it can be found in the radical sign or the exponent. The next is our du is x dx. So this is our u and this is our du. So we have to substitute this to u and du. So we have integral of this is du over our u, then squared, is equals to, so let's recall the formula for this. So again, let's recall the formula for this. So du over u is equals to ln equals to ln u plus c. So this is the formula, and then we have to write this ln then u squared plus c. And then we have to substitute u to x plus 3. So we have ln of x plus 3 squared plus c. So this is the final answer for our example number 1. So we have example number 2. So we have the example number 2 is integral of e raised to x squared minus 2 x dx. So we will let u is equals to, so as I said earlier, our u can be found as our exponent, can be found in radical sign, and can be found at the inside the parentheses. So we have the exponent, which is x squared minus 2, and then our du is 2x dx. So we have to add this here, 2, and then add this as negative 1/2. So equals negative 1/2 integral of e. So we will substitute this as our u times du, because our du is 2x dx equals the negative 1/2 e raised to u plus c. So let's recall the formula for eu plus c. So we have the formula, that is the integral of e raised to u du is equals to eu plus c. So our final answer is negative 1/2 e. Our u will substituted by x raised to 2 minus 2 plus c. And this is our final answer for our example number 2. And that's it for our u substitution. So let's move on to our next lesson, that is the integration by parts. So we have integration by parts. By parts. So our objectives in this lesson is to learn on how to integrate by parts. So we have the formula. That is the integral of u dv is equal to uv minus the integral of v du. So don't forget that formula. So we have the example number 1. Example number 1 is integral of x cosine x dx. So we'll find that our u, here, we'll write it here. Our u is x, and then our du is dx. Our dv is this cosine x dx, and our p is the derivative of cosine, that is sine x. So we have to substitute it as our formula. So u is x, and then v is sine x minus the integral of v sine x. Our du is dx. So copy this x sine x minus the integral of cosine x. The integral of sine x is cosine x plus c. So this is the final answer for our example number 1. So let's go to our example number 2. So let's go to example number 2. We have integral of x raised to 6 e raised to x dx. So in this case, we are going to use the DI method, or the differential integral method. So we will write it there, DI method. So this is the differential and this is the integral. So we have to column it. So our d is, this is our u, and this is our dv. So our u is x raised to 6, and then the derivative of x raised to 6 is 6x raised to 5, and then the derivative of this is 30x raised to 4, then 120x raised to 3, and then derivative of this is 360x squared and 720x and 720, and then 0. So we have here our I is ex, e raised to x. So the derivative of e raised to x is e raised to x. So same here, because the derivative of e raised to x is e raised to x. So we have to put the signs. This is, we will start at the positive, negative, positive, negative, positive, negative, positive, and negative. We have to circle it. So we have here the, when you combine it, that is the x raised to 6 e raised to x, and this is the negative 6x raised to 5 ex, and then this is positive 30x raised to 4 ex, and then this is negative 120 x raised to 3 ex. And this is 360 x squared ex. This would be negative 720x e raised to x. And last is the 720 ex. So our final answer here is this. You will copy that as x raised to 6 e raised to x minus, that is minus 6x raised to 5 ex plus 30 x raised to 4 ex minus 120 x raised to 3 ex. So we will write it there, 120 negative 120. So we will plus the 360 x squared ex minus 720 x ex plus the 720 ex and plus c. So don't forget to write the c. And this is our final answer for this example. So that's it. So thank you for watching this video, and I hope you learn from my video. And that's it. Bye!